Would you like to pay millions of penalties for bugs in your software? I guess not, but if you're coding anything that touches money, you should watch this video.
Bugs in financial software.
In 2009, a bug was discovered in investing software. The bug was related to decimal numbers and percentages. The owner of the company kept that information secret, and the bug caused a total of $217 million of losses due to bad investments. A tiny mistake brought enormous consequences, just like the NASA bug. In 1999, a Mars probe of over $100 million was destroyed just because the engineers confused the metric and imperial systems.
How do computers work with fractions?
Let's say we want to add 10 cents and 20 cents, which are represented by two decimal numbers. In JavaScript, it would look like this. For some reason, the result is not the expected 0.30. That error does not appear if we add 10 and 20 as integer numbers. So what happened here? Well, if we enter a number with a period, in fact we're using a so-called float type, which often stores only an approximation of a decimal number. Internally, float is a scientific notation to cover a range of numbers that's a lot bigger than integer. The base in this notation is 2, not 10, which causes conversion errors. It's not okay for money. Let me show you how small mistakes can accumulate and cause trouble. Imagine you're saving money, but with every penny there is a miscalculation in the system, and you end up with less money that you put in. Well, you could round this value up, but rounding is tricky, and here's another bug that I once had to fix in production. So, a person was trying to set a price to 4.10, but the program decreased it to 4.09 just because of a bad rounding system. Now imagine what could happen if you're handling different currencies where the exchange rates require even more precision of 4 digits after the decimal point. And the losses could be even worse with the stock market. In another example, let's see how we calculate a tax. We have a net price of 1.49 and want to add some 23% tax. The result has 4 digits after the decimal point, but it's not a valid amount in our currency, which allows only 2 digits. We have to round this either down to 83 or up to 84, depending on the local law. Now, this should be basic knowledge taught at programming classes, but for some reason most teachers do not tell you this.
Decimal types.
In most popular programming languages, there isn't a decimal type you could use out of the box. Java has a big decimal class, JavaScript has dedicated libraries on NPM, PHP has extensions that have to be activated. On the other hand, C# has a decimal type and decimal literals with the M suffix. SQL databases support decimal or numeric types as well, so you only need to specify a proper type when creating a table column. To sum up, if you need precise decimal operations, you must use a dedicated decimal type.
Money pattern.
In a book called Patterns of Enterprise Application Architecture, Martin Fowler came up with a money object to hold a monetary amount. This concept joins two fields in one structure, an amount and a currency, so we don't mix up the values of different currencies. It makes sense even if your application is using only one currency at a time, because it will be a lot easier to change it in the future or to introduce multiple currencies. Yes, a country currency may change, and the company might want to explore new markets. What's more, this class offers basic operations like adding, subtracting, and comparing. The idea is to have all these monetary calculations enclosed in some library that is well tested, so you can trust it. And yes, most languages already have dedicated money libraries that implement this pattern, and I will cover them in separate videos.
Sending amounts over APIs.
There are no standards when it comes to sending monetary amounts over a network, so every API may have a different format. This is dangerous, and I heard a story about a system that integrated multiple parcel delivery APIs. Some of them expected cents, some of them wanted dollars, and the coder confused these systems, so parcels were overpriced and the company lost hundreds of thousands of dollars just because of one multiplication that shouldn't be there. Here's a bad example in JSON. We have a price field that's just some float value, but we don't know exactly what it is. My advice is to use an integer or string, not float. Specify if it's a decimal or integer amount. always specify currency, and treat the whole amount as one object.
Currency conversion.
To convert between currencies, you need to know an exchange rate. I already said that it's usually a number with 4 digits after the decimal point. We need to get it somewhere, and it has to be up to date. There are many APIs that offer exchange rates. Some of them are free, some are paid, depending on what currency pairs you need. Pick one that suits you, then download the data every couple of minutes and cache it, so you don't have to ping the API every time you need a rate. To avoid trouble with currency conversion, always have a proof of the rate that you used. Save the source and the exact date and time you got that rate. You also need to remember that while most currencies have 2 decimal places, some have 3, and some currencies have no decimals at all. This is where the money libraries come in handy, as they hold this information. If you need an integer representation of currency, a library will prepare it for you. Do not multiply it by 100 or 1000 on your own.
Regions and languages.
Did you know that a $sign is used not only for US dollars, but also for Mexican peso, for example? It can be confusing that the same symbol has a different meaning in a different country. Also, the numbers might be written down in a different format. This is why we have a concept of a locale. It's a combination of a language and a region. If you're writing software that works internationally and with different currencies, you need to take care of localization.
Range of numbers.
You need to think about how big numbers your app will have to handle. $1 million or €1 million looks like a big amount, so you may think an integer is enough. But due to hyperinflation in some countries, you might be surprised if you run out of range. In Hungary in the 1940s, there was a time when prices doubled every 15 hours, and $1 was worth trillions of local currency, which eventually became garbage laying on the streets. In Germany in the 1920s, banknotes were used as wallpaper because they were cheaper than the actual wallpaper. A more recent example is Zimbabwe. As Wikipedia says,
by late 2008, inflation had risen so high that ATMs where one major bank gave a data overflow error and stopped customers' attempts to withdraw money with so many zeros.
You can find a lot more examples of hyperinflation and currencies being denominated and replaced, so as a software developer, keep in mind that you need to prepare your code for extreme situations. Fortunately, the money libraries that I mentioned earlier often use strings to store amounts internally, which gives you an almost infinite range.
Creating financial documents.
Every e-commerce or financial app generates documents like bills, invoices, or summaries. You want these files to be without mistakes, right? I've worked for a company which created thousands of invoices every day. If I made a bug in that code, the telephones would not stop ringing and the company could even get sued. This is why the code that calculates an invoice or a summary need to be clean and very well tested. It's a good practice to separate concerns. So for example, you have one piece of code that retrieves data, a repository, one piece of code that does the math, a domain layer, and another piece of code that builds a web page, a PDF or an XML, a presentation layer. Now, the code that does the math requires the strictest unit tests possible to check every possible scenario. Because you have presentation concerns separated, you only focus on the math and the business logic. For a repository, you write some kind of database tests, and for presentation you check whether all the required data are properly placed on screen or paper. Thank you for watching this video. I hope this advice will help you make better software. Keep your eyes open for more videos. Bye!